In this lesson, we are going to talk about the atomic structure and molecules. We start by the outline. So we first begin by the atom, and after that we talk about atomic number and mass number. Also, we'll talk about the isotopes, molecules and compounds, and we finish by talking about the chemical formula. As learning objectives, so at the end of this lesson, we'll be able to determine the component of an atom, also to understand the meaning of isotopes, to know how to differentiate between the atom and the ion, also to understand the organization of the periodic table, and also to know how to use the chemical formula. So we start by the atom. So atom is the smallest particle of an element, and so the atom is the smallest particle of an element. And in order to show how it is small, or the atoms are small, we can, if the atoms were arranged to make a straight line, so it would take about 100 million atoms to extend a distance of 1 centimeter long, which is an impressive number. Also, the atoms have the same properties of their element. And also the atoms of the element 1, they have the same properties of that element. And the same thing for the atoms of this element 2, they have the same properties of the element 2. But the atoms of the element 1 are different from the atoms of the element 2. Atoms has an internal structure. So what is the internal structure of an atom? The atom is made up of subatomic particles that are the protons, the neutron, and the electron. So we can say that atom has subatomic particles. And these subatomic particles are the proton, the neutron, and the electron. And these subatomic particles have a mass and a charge. We can see here that the proton and the neutron, they have almost the same mass. We can see the magnitude of this mass, how they are small. But the electron is smaller than these two subatomic particles. And also, if we calculate the relative mass to one electron, we can see that the protons and neutrons are massive compared to the electron. So these two subatomic particles are massive. They are about 2000 times heavier than the electron. And also, these subatomic particles, they have also a charge. The proton has a charge of +1. The electron is negatively charged, -1, while the neutron has no charge. So the proton has a positive charge, the electron negative charge, and neutron, it has no charge. And the charge of the proton is the same as the charge of the electron. So they have +1, -1, and 0. Now, how these subatomic particles are arranged in the atom. So we can see here that the protons and neutrons are found within the center of the atom, as we see here. And this center of the atom is called nucleus. So we have the nucleus, which is found at the center of the atom. And also this nucleus is an extremely dense material. It is extremely dense material. It has a high density with Because it is composed of protons and neutrons, so it has a charge. It is positively charged. It has a positive charge. Because it is composed of protons and neutrons, so the charge results from the presence of the protons. And also, as we've seen before, the protons and neutrons are massive particles, so they are heavier than the electrons. So the nucleus represents most of the mass of the atom. So it represents about 99.9% the mass of the atom. The mass of the atom. So we can say that all the mass of the atom is concentrated within this very tiny volume of the atom. And around the nucleus, we have the electrons that are moving quickly around it. So we have the electrons just around the nucleus. They are in motion. They move rapidly. And also the electrons, we know that they are negatively charged. So there is a negatively charged electron cloud around this nucleus. They are moving quickly, so they form an electron cloud which is negatively charged. And also the motion of the electron determines the size of the atom. The size or the volume of the atom. So we can say that the more the electrons are, or the more the electrons are found within an atom, and the larger will be its size. Let's do this example. So approximately the diameter of an atom is about 20,000 times greater than that of its nucleus. So here we can see the difference between the diameter of the diameter of the nucleus and of the atom. So the diameter of the atom is about 20,000 times greater than that of the nucleus. So here we add unity. Here we have the nucleus and here we have the atom. So the question is, if a nucleus in an atom were magnified until it is the size of a basketball, about 24 centimeters in diameter, what would be the diameter of the atom in meter and in kilometer? So if it were magnified to a diameter of 24 centimeters, so what would be the diameter of the atom? So the same thing, in the same calculation, we have to multiply the diameter of the atom by 24. So we get here about 480,000 centimeters long, and here we have 24 centimeters. So the diameter of the atom will be about 4,800 meters or 4.8 kilometers long, which is about 5 kilometers long, which is an important diameter. So we can see, if we extend this diameter of the atom, if the nucleus were found at half distance, so the radius of the atom would be about 2.5 kilometers long. Here we have the radius of this atom. So we can see here how impressive is the value of the diameter if the nucleus were magnified to a form of a basketball. Now let's talk about the atomic number and the mass number. So each atom has an atomic number and mass number. Atomic number and mass number. And the atomic number Z is represents the number of protons in the nucleus. So the atomic number is symbolized by the letter Z, which represents the number of protons in the nucleus, and the mass number represents the number of neutrons and protons that are found within the nucleus of the atom. The mass number, it has a symbol of A that represents the number of protons plus the number of neutrons. We can write again Z plus the number of neutrons. That is the mass number. So each atom is characterized by atomic number and mass number. For example, nitrogen atom, which has an atomic number of 7, it has also 7 neutrons, which means that the mass number will be equal to 14. Now let's talk about the isotopes. The isotopes are atoms of the same element but with different mass numbers. So we can write here that the isotopes belong to the same element, which means that they have the same atomic number or the same number of protons, but they have different mass number or different number of neutrons. That are the isotopes. As we can see here, we have boron 10 and boron 11 that belong to the element boron. So each of these two isotopes or two atoms, both of them have 5 electrons, and also they have the same number of protons, but they have different number of neutrons. The boron 10 has 5 neutrons and boron 11 has 6 neutrons. So they have different neutrons, and also we can notice with these isotopes that they are found in a mixture, and in this mixture we have different abundance. For example, the boron 10, it's about 20% in this mixture, and the boron 11 is about 20 or 80% in this mixture. Now, how these isotopes are represented? So we use this writing to represent the isotope. So we have here this element that represents the atomic symbol, and on the bottom left we have to write the atomic number Z, and on the top left we have to write the mass number A. So this is how we write a nuclide. So a nuclide is written as follows: X, Z, and A. For example, the nuclide of carbon 12. 12 is the mass number. So we start by writing this symbol, the chemical symbol of carbon, which is C capitalized. Carbon 12 has 6 protons. So the atomic number is written on the bottom left. And the mass number is written on the top left. Here it is. So here we have a writing of the nuclide C12. So the nuclide of the carbon 12 is identified by this formalism. Now, how all the elements that we know are organized? We use a chart that is called the periodic table, and in this periodic table all the known elements are found, and these elements are arranged according to their atomic number. So in this periodic table we have all the elements that are arranged according to their atomic number Z. So here we can see that the first element of this table is the hydrogen, because it has an atomic number of 1. The second one is helium atom, because it has an atomic number of 2. The second line we start by the lithium with atomic number 3, beryllium 4, boron 5 until neon of 10. On the third line we start by the sodium, which has an atomic number of 11, and so forth. So we can see that all elements are arranged according to their atomic number. And also we can see that this periodic table is characterized by horizontal lines and vertical lines. So we can see that we have horizontal lines and vertical lines. So the horizontal lines are called the periods of the periods, and the vertical lines are called the groups of the periodic table, groups or families of the periodic table. Now let's talk about the ions. So what is ions? An ion is an atom that is charged. So the atom is neutral, but when the ions are different from the atoms because the ions are charged atoms. They are charged atoms. Why they are charged? Because in the atom, in a neutral atom, we have the number of protons is equal to the number of electrons. But in the charged atoms, we have the number of protons are different from the number of electrons. And for the ions, we have two types of ions. We have a positively charged atom or a negatively charged atom. The positively charged atom is called the cation, and the negatively charged atom is called the anion. The positively charged atom is obtained when one or more electrons are removed from the atom, and the anion, it is obtained when one or more electrons are added to the atom. As we can see in this equation, we have here the sodium, which results by the formation of the cation Na plus and electrons which are removed. Here we have only one electron that is removed from the sodium atom. But here for the chlorine, we have an electron that was added to the chlorine. So we have here the anion chlorine minus. So here we have these types of ions, but we can have, for example, we have here we have the sodium plus, but we can have more than the charge greater than 1. For example, the iron, we can form iron 2, and so forth. The same thing here, we have chlorine minus, but we can also have O2 minus, and so forth. So it depends of the number of electrons that were removed or added to the atoms. So we can summarize here from what you have seen until now. So the atoms can belong to the same element or to different elements. The atoms, if they have different atomic number, which means different number of protons, it means that they belong to different elements. So as a rule, different atomic number, it means that they belong to different elements. But if they have the same atomic number, which means they have the same number of protons, it means that they belong to the same element. And the atom that belong to the same element, if they have different mass number, which means that they have different number of neutrons, here we have the isotopes. and the atoms that belong to the same elements that have the number of their protons different from the number of their neutrons, here we have the ions. And ions, we said that we have two types of ion: cation, positively charged particle, and anion, which is negatively charged particles. So here we have the summary of the atoms. Let's do this example. So here we have different species. We are asked to determine the number of protons, neutrons, electrons, nucleons, and the total subatomic particles for each of the following species. So we have to draw a table. It's better to like this. So we start by the number of protons, neutrons, electrons, nucleons, and the total subatomic particles. So here the nucleons are the protons plus the neutrons. So it is the mass number. They are called nucleons because they are found within the nucleus. They are the nucleus subatomic particles. So we start by the first species, which is chromium, which has 24 and 53. So the number of electrons or the number of protons is 24. The number of neutrons is 53 minus 24, which gives 29. Here, so neutrons is obtained from this equation, A minus Z. The number of electrons, because it is neutral, here we have a neutral species, so it means that the number of protons is equal to the number of electrons, is 24. So we have two cases here. For the electrons, if number of protons is equal, here we have neutral. The nucleons are represent only the mass number, which is 53, and the total subatomic particles, so we have to add the protons, neutrons, and electrons, which gives a number of 77. So the same thing with the second species, which is the zinc. So we start by the number of protons, which is 30. The number of neutrons, as we have done here, so we have 37. The number of electrons, because it is a neutral species, which means that the number of protons is equal to the number of electrons, which is 30. The number of nucleons are the number, or the mass number, represent the mass number, which is 67, and the total subatomic particles is obtained from this sum. So we have here 30, here we have 97. The third species, which is magnesium, the ion magnesium plus 2, 12, 24. So we start by the number of protons, which is 12. The number of neutrons is 24 minus 12, which gives 12. The number of electrons, here we have a charged species, which means that the number of protons is different from this number of electrons. Here we have two electrons that have been removed, which means that the number of protons here will be 12 minus 2, which gives 10. The number of nucleons are 24, because they are the sum of protons and neutrons, and the total subatomic particles is equal to 34. The last nuclide is the bromine 3579, with a charge of -1. Here we have the number of or the number of protons is equal to 35. The number of neutrons is 79 minus 35. Which is 44. The number of electrons, because here it is charged species, it is an ion, and so one electron has been added to the bromine, which gives a number of 36. The number of nucleons is 79, and we have to sum all these numbers. So we have here 35 plus 44 plus 36, which gives a number of the total subatomic particles of 115. So that's the example. That's the answer for this example. Now let's consider the molecules and compounds. So a molecule is an aggregate of at least 2 atoms. So a molecule is composed of at least 2 atoms or more. So for example, molecules, we have water, ethanol, hydrogen gas, and so forth. And molecules can be classified into 2 categories: a homoatomic molecule and heteroatomic molecule. So what's the difference between homoatomic molecule and heteroatomic molecule? So we have here molecule that is homoatomic or heteroatomic. So in homoatomic molecule, we have a molecule that is composed of the same kind of element. So it is made up of the same kind of element. For example, the hydrogen gas, chlorine gas, oxygen gas, and so forth. But the heteroatomic molecules, this type of molecules are made up of different type of element. For example, water, H2O, carbon dioxide, CO2, carbon monoxide, and so forth. So the heteroatomic molecule is composed of different type of elements. And when we have one type of element in a molecule, we can say that this molecule is an element. So we have a pure substance that is element. And when we have a molecule composed of different type of elements, we can say that this pure substance is a compound or a molecular compound. And also a molecule can be either diatomic molecule or polyatomic molecule. So a diatomic molecule means that the molecule is made up of only 2 atoms. Like for example, hydrogen gas, oxygen gas, carbon monoxide, and so forth. And for the polyatomic molecule, we have at least 2 or more atoms. So it is a molecule that is composed of 2, 3, or more atoms. Like the water, ethanol, carbon dioxide, and so forth. So we have reviewed the type of molecules that we have. And now let's talk about the chemical formula. A chemical formula shows the atomic symbol of each element followed by its numerical subscript in order to indicate the number of each element in a molecule. So a chemical formula is written in order to show the type of element that is found in the molecule and its numerical subscript in order to show the number of each element. Like when we say hydrogen, here we have the hydrogen, it is the element, and the numerical subscript to shows how many atoms we have in this molecule. Or water, H2O, here we have the chemical symbol H and O that shows the element, and here we have 2 in order to show the number of the element in this molecule. Here we have to note that the oxygen doesn't have a numerical subscript because we have only 1, and when we have only one element, so we don't have to add a numerical subscript, so we don't add it. Like for example carbon dioxide, we don't add a 1 here, or carbon monoxide, we don't add 1 or 1. So we add the numerical subscript only when it is greater than 1. So now, after having seen the molecular formula or chemical formula, now we'll talk about the molecular representation. How do we represent molecule? As example, we have taken the methanol. So this substance can be represented according to different representation, as we have here. So we talk about representation of molecule. We have the first one, the A representation, that is called the molecular formula. This representation is the most common form that we see in books and other documents. It is the most used one, and sometimes we can call it the condensed formula. Also, we have the second type of representation, which is called the structural formula, as we have here. It is the structural formula. The structural formula shows how the atoms in the molecule are connected between them. And the third representation, which is called the perspective. It is a perspective representation. So the perspective representation shows how the molecule is arranged in three-dimensional space. Also the formula, which is called the ball and stick. Here we have this small ball and this stick. And the last one, which is called the E form, it is called the space filling formula. The space filling model. Space filling model. So to finish this part of molecules and compounds, we do this third example. So here we have 4 types of substances, 4 different types of substances. So we are asked to determine which of the following diagrams represent a diatomic molecules, a polyatomic molecules, molecules that represent an element, and the molecules that represent a compound or molecular compound. So we start by the first one, the A. So example 3, we start by the A. The A, we can see that we have a pure substance And here we have this molecule. We have a group of molecules. They are the same. We have this different color. Each color represents one element. It is a convention method to represent elements or atoms of different elements. For example, here the black color is for the carbon and the white color is known to be the hydrogen. So here we have CH4. So here we have first, if it is a diatomic molecule? No, it is, because it is composed of more than 2 atoms, and so we have a polyatomic molecules. So the A is a polyatomic molecules. And also if it is a compound or an element, here we can see that it is a compound because it is composed of carbon and hydrogen. So it is a compound. Second example, here we have this pure substance that is composed, so each molecule is composed of 2 atoms. So we can see that it is a diatomic molecule. So it is a diatomic molecule. Dia, it means 2. And also each molecule is composed of 2 different colors. Here each color represents a different element. So we have element green and element white. So we have a compound here too. We have a compound. The third example, we have here a pure substance, and each molecule is composed of 3 types of atoms. We have 1 red color and 2 white. So we have 2 elements in this substance. It is composed of 3 atoms, and we have 2 types of elements, the red color and the white color. Here the red is the oxygen and the white are the hydrogen. So we have 3 atoms, which means it is a polyatomic molecule. It is composed of 3 atoms or 2 different type of element. So it is a compound, a molecular compound. The last one, we have a pure substance that is composed of 2 elements. So it is a diatomic molecule. Diatomic molecule, and we can see that the atoms are the same. We have the same color here, white colors. It is the hydrogen gas. So we have an example of a pure substance which is an element. So here we have the same element, which means we have an element here. So that's for the third example. So now let's summarize what we've seen until now. So each atom of an element contains the same number of protons, which is the number atomic number. Also, atoms of an element that contain different numbers of neutrons are called isotopes. Neutral atoms have the same number of electrons and protons. Also, when one or more electrons are added or removed from an atom, a charged particle called an ion is produced. Also, a molecule is an aggregate of at least 2 atoms held together, as we have seen, by chemical forces. A chemical formula shows the element in a molecule followed by its numerical subscript in order to say how many types of these atoms are present in this molecule. And last, a molecule can be written according to different representation. As we have seen, it can be written like a molecular formula, in a structural formula, in perspective or space filling model. And that's all for this lesson.